Welcome, everyone. Thank you very much.
Thanks, chaps.
Yeah.
Good to be here again. Been a while.
Yeah. So we are now going to be kind of building off of the amazing presentation delivered by Tobias just previously around 6 gigahertz. And we've got some tips and some tricks that we're going to talk through. We're quite fortunate recently, we've both got some 6 gigahertz access points and some 6 gigahertz client devices. So we had the pleasure of doing some tests that we're going to share some results with you. So I know Tobias was really challenging you to think outside the box with how you're going to be configuring some of your SSIDs in the future. Hopefully this will give you a bit more of a picture on how you may want to not only configure your SSIDs, your network names, but also perhaps your channels. So just for the cameras, quick round of introduction again, Mac.
Yes, Mac, Directors, EKH, ECSE, and Product Marketing. Hello.
We just want to make sure that everybody is on the same page when it comes to 6 gigahertz because there is so much to learn and so much new cool stuff that comes with 6 gigahertz. So first of all is the amount of additional spectrum that we're getting. So in the States, Tobias mentioned earlier that they get a big chunk of additional spectrum, 1.2 gigahertz, which equates to 59 20 megahertz wide channels, 29 40 megahertz wide channels, 1580 megahertz, and then 760 megahertz wide channels. And what we've got highlighted down here below is something called the PSC channels, which is very important when it comes to discovering the 6 gigahertz wireless networks, which we're going to talk about in a couple of slides' time in a bit more detail. But again, Mac, if you can just recap EU, what are we doing?
Yeah, so we are not as lucky in the EU and the UK as the chaps in the States, because we don't have 59 channels in 6 gigahertz spectrum band, we have 24, which equals half a gig of spectrum, roughly. That's what we have access to instead of 1.2 gig. And also we have PSC channels here, but not too many. Just 1, 2, 3, 4, 5, 6 of them. That's all we have to play with in the EU. Yep.
So we're going to talk about discovering 6 gigahertz wireless networks because it's a little bit different to how we do it currently in 2.4 and 5 gigahertz. So I'll just cover the out-of-band discovery as of right now, and that is going to be something that's called RNR, or Reduced Neighbor Report, which is quite interesting. It's very cool. We haven't had this before when it comes to Wi-Fi. So what happens if you've got a 6 gigahertz access point where you've got 2.4, 5, and 6 gigahertz? The 2.4 or the 5 gigahertz radio inside that access point can inform the client device about its co-located 6 gigahertz radio, which is going to be important when it comes to discovering wireless networks. So that's...
Will it do that if you don't have a 2.4 or 5 gigahertz?
Wait for it.
That is a very good question. So our friend in the audience, he's asked us, will our access point still inform the client device if the 2.4 or 5 gigahertz radio isn't on? And again, I didn't slip him £20 before the show, but we had the exact same questions in our mind, and we just so happen to have tested that. So if you just hold on a few slides' time, we will get to that, and we can actually share the results with you, with everybody. So that's the out-of-band discovery. Another question that we had when it comes to the reduced neighbor report was, do I need to have the same SSID on each frequency band? So do I need to have Ekahau Corporate broadcasted on 2.4, 5, and 6 gigahertz for this reduced neighbor report to work? Because we were talking about it earlier, and we talk about it a lot, but we sometimes don't necessarily want to have the same SSID broadcasted across every single frequency band, because when it comes down to the decision of what frequency to connect to, it's always from the client device's choice. And if you have the same SSID across all the frequency bands, then you can't control necessarily which one they're going to be connecting to. So we wanted to test it out. So we have a 6 gigahertz capable access point that we was using, but we did configure single band SSID. So one SSID on like 2.4, one SSID on 5 gigahertz, and then one SSID on 6 gigahertz as well. And the capture that we're looking at here is from the 5 gigahertz radio. And what you'll see is inside of the information element, we have this new field here called the Reduced Neighbor Report, which we can see. And I'll just go to the next slide because you can see it, and a little bit more information here is that we can actually see that it is telling us from its 5 gigahertz radio about the channel number for its co-located 6 gigahertz radio. So from the 5 gigahertz single band SSID, not broadcasting the same SSID on 2.4 or 6 gigahertz, has informed the client device about its co-located 6 gigahertz radio. So you do not have to have the exact same SSID being broadcasted across all 3 frequency bands or multiple frequency bands to leverage reduced neighbor report. The question from the audience that we had earlier, but if we disable the radios, that's coming in a few slides' time. Mac is going to talk you through some in-band discovery right now.
Okay, so in order to understand it a little bit better, let's take a step back and think about how does discovery work in 2.4 and 5 gigahertz bands. And in these two legacy bands, everything happens in band, okay? So if you have a device operating in 5 gigahertz band, you will be looking for a radio to associate to or reassociate ROM to on the same band. And you had two options. Either you were waiting for beacons passively, so we are dwelling on a channel for like 120, 105 milliseconds to listen for at least one beacon on this particular channel, or if you were not on a DFS, radar-affected channels, you could also send probe request, and then the access points on this channel will send you back the probe response. And that's how you discover the APs. So that was all in band. Now you can see that we don't have any of that in 6 gigahertz. So we don't use the same discovery methods. Matthew has talked us through the RNR, reduced neighbor report, which is out of band. So we are using collocated radios to discover 6 gigahertz radios. And now let's take a quick chat. Let's have a quick chat about these two discovery methods in band. First one is called FILS, a fast initial link setup. And as we understand it today, most vendors, they have agreed that they will not be using FILS moving forward because FILS is like a lightweight version of a beacon that is being sent not every around 100 milliseconds, but every 20 milliseconds. So you have tons of these little tiny FILS, small little tiny beacons being sent, contributing to overhead. Is it possible to leverage that to discover 6 gigahertz? It is. But it's not too practical, okay? So that was FILS. And the next one, the very important one, is the PSC. PSC, it means the preferred scan channels that we are scanning every 4th channel. So if we have 59 channels in states, we will have 15 PSC channels to scan through, and this will be way faster to discover the channels, 15 of them, instead of 59, right? That's why PSC is like an equivalent to our current traditional in-band discovery methods on 2.4 and 5 gigahertz. And in Europe, we have less. We have 6, right? Because we have half a gig, not 1.2 gig spectrum.
Yeah. So we asked this question when we was at a previous Wi-Fi conference. Now, based on the information that you have heard from the Bias's presentation and just the little bit of information that we've covered, we have a question for you. When you are going to be coming to designing and deploying your 6 gigahertz wireless networks, what channel width are you planning to use? So I'm just going to go a quick show of hands for anyone planning to use 20 megahertz wide in 6 gigahertz. Okay, we've got just you on your own, my friend. Okay, one person for 20 megahertz wide. How about 40s?
Okay.
40s seems quite popular.
Half?
About half the room. Interesting. 80s?
Okay, so I would say 70% 40 megahertz.
Yeah, okay. And anyone going to do 160s? We've got a couple of hands went up, and I heard someone say, if I'm at home. Yeah, there may be a time and place for it, but how many people here use anything larger than 20 megahertz wide channels on 5 gigahertz currently when you're deploying? A few people? Okay. Do you use 80 megahertz wide channels for 5 gigahertz deployments currently now? Yeah. Yeah, I guess there's a use case and a time and a place for all of them. But when you're in a busy enterprise environment where you've got lots of neighboring wireless networks, typically what we found is that you want to do is use 20 megahertz wide channels because that's going to give you the best channel reuse and keep your contention to a minimum. So keeping that in mind, that we probably would want to be thinking about that when it comes to 6 gigahertz, because one question that we wanted to ask everybody in here is, what is one of the biggest performance killers in Wi-Fi? CCI, contention, correct. So yeah, we call it contention, CCI, ACI, primary, secondary, OBSS interference, which we're going to talk about in a minute. If you're wondering who would win in a fight, it's obviously me.
It's actually not the case because Matthew is hitting like a lady, so he's not the biggest performance killer.
I just throw my handbag at him. So if anyone that's not familiar with like the terminology of that primary, secondary, OBSS interference, Mac can give us a quick...
Yeah, sure. So guys, it's very important to understand the concept of a primary channel here. So let's spend 10 seconds plus on it. This is the ideal world scenario where we have two radios operating on 40 megahertz channels that are not contributing to CCI. These radios, they do not overlap. They are adjacent, but they don't overlap. So life is good. And you highlighted channel 36 on the first radio and 44 on the second radio. These are primary channels. And now we have to understand that the primary channel is the channel used to exchange most of the control and management traffic, and Wi-Fi is a very polite protocol, right? So every single Wi-Fi device listens before it talks, and if someone else is talking, it can be Wi-Fi or even non-Wi-Fi, we listen to it on a primary channel. Primary channels are always 20 megahertz wide. So even if we are using 80 megahertz channels, we will tune into this 20 megahertz smaller channel to listen before we talk. And why is it important? Here, it doesn't matter too much, but when we move to the next slide, Matt will talk you through why this is a problem.
So what you're looking at here is two co-located access points in the same vicinity. The top one being the BSS1, and then we've got a second access point here, BSS2. But what's happened now is that rather than them being separated and not sharing the same channel at all, they are both occupying channel 36 and channel 40 on 5 gigahertz. But the issue that you see here is that rather than both of their primary channels lining up on channel 36, one is on channel 36 and the other one is on channel 40. So what happens is that, let's say access point 1, it listens, do I hear another Wi-Fi device transmitting on the same channel? And because it's overlapping with the secondary channel of the other access point, where the other access point is using channel 40 to check, listen, do I hear another Wi-Fi device transmitting on this channel? Because it doesn't, what happens, you'll see, and the biggest performance killer in 5 gigahertz is probably this, basically, they will just try and transmit over the top of each other, which will cause collisions, which therefore translate to having more retransmissions and therefore poorer performance in your Wi-Fi network and a degradation to the performance. So it's one of the biggest problems really when it comes to 5 gigahertz and wired channels. And then we was thinking, well, surely we're not going to have this problem when it comes to 6 gigahertz, are we? Why not?
Do.
Yeah, of course. So here is a validation survey done of our lovely Helsinki office where we've got multiple different 6 gigahertz access points currently deployed. Mac is smiling because he really wants to highlight a few channels.
So this is the design done by our technical lead, Miko. Have you ever heard of him? So that's what he does when he designs networks. And you can see a mixture of like 160 megahertz channels, some 20 megahertz channels. So when you have some overlapping channels and mix of channel widths, then you're asking for trouble. You're asking for this OBSS, primary, secondary OBSS. And this is really a massively problematic thing. If you don't see it here, let's move to the next slide. And now you can clearly see that we have, 20 megahertz channel, 20 megahertz channel, then some 40 megahertz channel on top of it. So if we have 20s inside of 40, multiple of them, we will have primary, secondary OBSS. We will have collisions. We won't have acknowledgements for our unicast traffic, which leads to retransmissions, which leads to spending more time on contention window timers, which slows down everyone. We don't want that, right? So this is really, really bad. Try to avoid it. And now a pro tip here is to always stick to the same channel width across your entire network. Don't mix and match, okay? Just don't.
Okay, so we're not the only ones that's got some questions when it comes to 6 gigahertz. There's lots of people online talking about some specific things they would like us to test and questions that they have. We had tons of questions. So we have this guy, Curtis, here, who was very curious around the new Wi-Fi 6E capable iPad, the iPad Pro, connecting to a wireless network with the same SSID being broadcasted on 6 gigahertz and 5 gigahertz. If we get this limited compatibility message, or if you was to disable the 5 gigahertz radio, does it go away? Well, we thought this was an interesting thing to test, and we have some 6 gigahertz access points, and we've just got the 6 gigahertz iPad Pro, so we're like, well, we'll definitely test this out for you. So what we got here is obviously our Echo Sidekick 2, which is 6 gigahertz capable. We had, in my environment, I've got a Cisco Meraki 9164i. We've got an iPad Pro, which is 6 gigahertz capable, plus a Pixel Pro that is 6 gigahertz capable. So we wanted to test out Curtis's theory, and what we did, we set up a couple of SSIDs, one called Echo 5 and 6 gigahertz, which is broadcasting on, you guessed it, 5 and 6 gigahertz.
No
and
way.
Then the Echo 6 gigahertz, which was just broadcasting on 6 gigahertz only. Then what I did is I connected my iPad to the 5 and 6 gigahertz network, and I didn't get any compatibility issues warning. But when I connected my laptop to the my iPad Pro to the 6 gigahertz only network, I did get the limited compatibility warning message. I was able to use the 6 gigahertz network, no problem at all, but for some reason Apple was throwing a warning to say that we have some limited compatibility. So one thing to keep an eye out. I didn't have any problems using the network, but one thing to think about for sure in the future. And we had another question. I think like someone else in the audience had this question.
Yep. So what if we had only the 6 gigahertz radio broadcasting? So we have disabled 2.4 and 5 gigs. We have disabled co-located radios, and we started testing it. So let's move to the next slide. And then Matt's iPad was like, dude, where's my 6 gigahertz? He couldn't find it anymore, right? With like 6 gigahertz alone, without 2.4 and 5.
Yeah, so even though the 6 gigahertz SSID was still there and it was broadcasting, my Apple iPad couldn't see it. Yeah. It was just like it completely vanished, even though it was there.
What the heck?
Yeah, but however, I did have the Pixel Pro, and the Pixel Pro was like, no worries, dude, I got this. Hold my beer. Pixel Pro was able to discover the Ekahau 6 gigahertz SSID, whereas my iPad Pro not able to discover it at all, which then led us to the conclusion that Apple devices, as of right now, they need to have co-located radios to use reduced neighbor reports to be able to discover 6 gigahertz wireless networks. So that was quite an interesting test, whereas the Android devices, from our testing so far, they can use reduced neighbor report, primary scanning channels, or fields to discover the 6 gigahertz wireless networks.
Yep. So then we thought that this few tests alone, they probably wouldn't be enough to fill in our 30-minute slot, right? So we had to do something else, a little bit more. So this is what we've tested. So first, we've tested dual band SSID with 5 and 6 gigahertz on PSC channel, okay? On PSC channel, that's quite important.
80 megahertz wide PSC channel.
Yes. Then we've done the same test with non-PSC channels, and we've done a single band SSID test with PSC and non-PSC. So we've done like 2 tests on PSC and non-PSC, 5 plus 6 and 6 alone. We've tested multiple vendors, and we've tested multiple devices as well, so Google and Apple. Let's move to the next slide quickly. This is like all the tests that we have done. So I can see like everyone's like,
yeah, just take all that in, guys. Not a lot of information there, but please feel free, take a picture of this if you want, or it will be inside of the presentation when it gets recorded.
Yeah, but this is quite fascinating, because when we are that's number one, first row, when we are using 80 megahertz PSC channels, and we have co-located 5 gigahertz radios, vendor A and vendor B, we have 2 different vendors, both iPad and Pixel, they can connect, no problem, okay? They discover 6 gigahertz, the life is good. The second row is where the test is very similar. We have 5 and 6 gigs, but now we are using non-PSC 6 gigahertz channels. So we have to scan all the channels, not just 6 in the EU, in order to discover this stuff. And iPad and Pixel Pro would still connect, because they would still use the RNR. So first to test, doesn't matter if you are on PSC or not. You can use all the channels. You can use 20 megahertz on 6 gigahertz band. That's absolutely fine and encouraged at the same time in high-density environments. And it's still going to work because of the out-of-band discovery, RNR, reduced neighbor report. Important. Apple needs it, okay? And it works with pretty much everything currently we've tested on the market. Now the test number 3 is PSC channel on 6 gigahertz and just 6 gigahertz SSID. Now, we think this is a corner case, because you really won't be just relying on 6 gigahertz, surely. If you have free band radios, as Tobias were saying, you will have IoT on 2.4, you will have guests on 5, maybe corporate on 5 and corporate on 6, and you want to have that. RNR will work, so this is a corner case. And with no PSC, with PSC channel, but no RNR, iPad couldn't see the network. It was like, what the hell, where is it? It's gone. And the Pixel was still right. And now the last test, the same, single band SSID, 20 megahertz wide, this time or 40 megahertz wide it was, on non-PSC channel, and on vendor A, both iPad and Pixel couldn't discover it because there was no RNR, there was no PSC, but on vendor B, in my lab, my Pixel could discover non-PSC. It means that my Pixel must have been using fields. That is probably on its way out. So the conclusion here is RNR for the win. Even if you want to use single band SSID with just 6 gigahertz, make sure that you at least have a dummy SSID on one of the legacy bands, even if it's just for the RNR.
Yeah.
Okay?
The other thing just to point out here as well is obviously this is our testing in March 2023. when Apple or Android rolls out a software update, the client devices, they may behave differently. So we always recommend testing with the devices you're planning to deploy on the current firmware version. So that's a good thing to just bear in mind. And we threw it out there to the UK Wi-Fi Slack channel around, does anyone else have any other questions on 6 gigahertz that you would love for us to answer and we could test out? And a good friend, Harry, I think you're here today, Harry, right? Are you here? There he is.
Hi, Harry.
Harry, a wave. Harry had a question. His question was around how does he configure his SSIDs with security around 6 gigahertz? Will he need to separate his SSIDs, or will they work if they're not separate? Some customers fight the idea of having separate SSIDs, which is a very good question because a lot of us are confused or considering how should I be implementing my wireless networks? Do I have single band SSIDs? Do I have to have the same SSID across multiple bands? When it comes to security, device was mentioned about it earlier, WPA3, transition mode, things like that. And then we had a few questions from our good friend Andrew McHale, who's not with us today, but he's here with us in spirit, around the speed of the devices being able to connect on 6 gigahertz.
But this is a tradition now to have a little bit fun about Andrew, right? So let's have it. Andrew McHale, also known as Andrew McFly, he's asked, which is quicker to join a non-6 gigahertz SSID, Apple or Google? So let's answer it for Andrew. It doesn't matter because it's a protocol and not a vendor thing at this point. So good question, Andrew. And now the good question is, which finds an unknown SSID quicker, Apple or Google? So in our test, we were measuring it with a stopwatch, and with 5 and 6 gigahertz enabled, there are different discovery scanning patterns for Google and Android, and Google was twice as fast as Apple here. It was taking 7 to 8 seconds for Apple to discover the 6 gigahertz SSID, and 3 to 4 seconds for Google. I guess that Apple was scanning 2.4 first and Google was scanning 5 gigahertz first. That's why it discovered it faster. That's it.
Okay, so let's try and answer the security question and around the SSIDs, how we're going to be configuring them, because when you are when you're using 6 gigahertz, it's mandated that you have to use WPA3. What also that means is that you have to enable something called management frame protection or protected management frames, or otherwise known as 802.11w. So let's say that you've got your SSID, Ekahau corporate SSID, and you decide that you've got a brand new deployment of access points that support 6 gigahertz, so you're going to broadcast your corporate SSID across 5 and 6 gigahertz. This means that effectively on your 5 gigahertz as well, this will potentially mean that you have to put WPA3 on plus protected management frames, which we're taking a look at the analyzer application. We can see here the first screenshot at the top. This is on 6 gigahertz. We can see that the security is WPA3 and management frame protection is required, but this is also the case for 5 gigahertz and for management frame protection on 5 gigahertz too. So when you're configuring your wireless networks, this is what I did in my home lab environment. When I'm configuring the 6 gigahertz, you have the option to configure WPA3 only, which will make it required for management frame protection for your client devices to be able to associate, or you can configure transition mode and have it for management frame protection to be enabled, but allow unsupported clients to connect as well. So what Tobias was saying earlier about WPA3 transition mode is inefficient, and you could potentially run into some issues if you enable that. I connected my iPhone to both of these SSIDs and it worked absolutely fine, no problem at all. But what is the biggest problems with your wireless networks?
Old crap devices.
Old crap devices. Yeah, you can't always control the client devices that are coming into the wireless network.
Yeah, so this is Matthew in a few years' time, holding his iPhone 3GS. I wonder if it's going to connect to the network when we enable WPA3.
If I can grow a beard half as impressive as that, I'll be quite proud.
And by the way, some vendors, they don't allow you to configure transition mode. So my vendor, it was either WPA2 or 3, no transition mode, probably for the best.
Yeah. So the problem is if you decide that you are going to blanket enable WPA3 across both your SSIDs on 5 and 6 gigahertz, well, you can't always control the client devices that are coming into your wireless network. So therefore, you could potentially have connectivity problems for the devices on 5 gigahertz because someone comes in with a device that doesn't support WPA3 or management frame protection, and then they're just not going to be able to associate. So our recommendation here, and pretty much it always is when we're teaching Ekahau classes or doing our webinars, is we always really are strong recommended fans of having single band SSIDs. If you want your client device to connect to a specific frequency, the only way that you can guarantee to control that is by having single band SSIDs. There's some things you can turn on like band steering and this, that and the other, but that doesn't guarantee that your 5 gigahertz client will connect to the 5 gigahertz radio, or even your 6 gigahertz client will connect to the 6 gigahertz radio. And then to take into consideration around the security as well, you could run into some problems there.
Yes.
Preach, yeah.
Yeah, look at that, guys. This is my Google Pixel 6 Pro sitting on my desk over a few days' time. And it started being connected to Ekahau 5 and 6 gigahertz dual band SSID. I didn't move my AP, I didn't move my Pixel, it was on the desk, and it was jumping between 6 and 5 gigahertz frequency bands. And I wasn't even moving. Now imagine if I was moving around the office, that would break havoc in your roaming and losing connectivity, especially when you are on a voice or a video call. Okay, so don't do it. Simply don't do it.
Yeah. The UK Wi-Fi Slack channel is pretty much our home. We've been there since we got into Wi-Fi, really. There's a lot of people in this room right now who are part of the UK Wi-Fi Slack channel. And if you're in the UK and you like Wi-Fi, which I'm going to guess you do because you're at a Wi-Fi conference in the UK, please, if you're not a part of the UK Wi-Fi Slack channel, scan this QR code. We have the gatekeeper here, I think, as well somewhere. And you can register to join the UK Slack channel. It's a great place for community, talking with your peers, especially in the UK. There's some really good conversations in there. And if you have questions about certain things, loads of people are more than willing to help you out and answer those questions. So please, if you would like to, just scan the QR code and join. And then finally, we get this question a lot because there's this new Wi-Fi standard just around the corner, right? Wi-Fi 7.
So what's your gut feeling, chaps? Will the Sidekick 2 support newer Wi-Fi generations moving forward?
Yeah.
Yes? Yeah. Of course it will, okay?
Yes. The answer here is yes, absolutely. The Sidekick 2 works on 2.45 and 6 gigahertz. The big thing about Wi-Fi 7 is it's going to be working across all those frequency bands. And the way that Wi-Fi standard and protocol is written, that any new generation of Wi-Fi has to be backwards compatible. So your Sidekick 2 absolutely will support Wi-Fi 7. There's no problem there, no concerns. You don't need to wait for Wi-Fi 7. You can get your Sidekick 2 now and it will work perfectly fine. And then we just wanted to leave a few key takeaways from the presentation. I know there's a lot of information from Tobias's 6 gigahertz presentation and our presentation as well, but some of the key things that we just wanted you to take away from the presentation today.
Yes, so guys, remember that with Apple devices you need to have RNR. This is super important, okay, very important. Co-located 2.405 gigahertz radios. Androids, they handle it, I wouldn't say better, they support more discovery mechanisms, but this more discovery mechanisms, it means potentially slower discovery. And it's a corner case because you will pretty much always want to have collocated radios turned on. Okie doke. And then fields is required on single band SSID with no collocated radios. I wouldn't rely on it because it's on the way out, most likely. And remember that every vendor will implement 6 gigahertz differently. Matt's vendor wasn't broadcasting fields, mine was. So don't rely on it.
Yep, and we still recommend single band SSIDs for even with your 6 gigahertz radios. You can have an SSID for dedicated 5 gigahertz radio, and SSID dedicated 6 gigahertz SSID and radio. How you configure those names, that's a problem for you guys to figure out, but we still recommend that you go with 6 single band SSIDs across your different radios. But it is important to remember to make sure you have got SSIDs broadcasting on the additional radios because the Apple devices currently right now, they do need to use reduced neighbor report.
Yes, and also guys, watch for the primary, secondary OBSS. That's the white channels overlapping, but not on a primary channel. This is a performance killer, number one. And also make sure that your devices across different bands, especially legacy bands, can support management frames protection or protection of management frames and WPA3. This is mandatory in 6 gigahertz. You have to support WPA3 and MFP. And if you have a vendor that enforces the use of WPA3 and MFP on 2.4 and 5 gigahertz band, the second that you enable it on 6 gigahertz band, make sure that your devices do support it, okay? We were doing some fancy tests at some of the big conferences where we had 100 devices associated on a 5 gigahertz radio. Then we enabled WPA3 and MFP, and this 100 has shrank to 2 devices being associated on the same radio. So yeah, compatibility can be an issue.
Yeah. And then finally, Sidekick 2 will support Wi-Fi 7. And that is it from the end of us today. We want to say just take this moment to say thank you to Ekahau, Open Reality, all the exhibitors, but most importantly, all of you for coming and making today such a fantastic day. Seeing all of you in person again, hanging out is so nice during the breaks, lunches, and later on we'll be around to grab a beer or a drink with you after on. So we want to say a massive cheers and a big thank you to everyone here.
Thank you very much, guys.